Bismillahirrahmanirrahim. Dear students, today we are going to learn about a very important topic of chemistry, that is similarities in the chemical properties of elements in the same group. A topic from chapter number 8, Periodic Table and Periodicity of grade 9. Let's study chemical properties of elements in the same group. Dear students, elements in the same group of the periodic table share similar chemical properties because they have the same number of electrons in their outermost shells. This fundamental principle explains why elements in the same group behave similarly in chemical reactions. In this presentation, we will also explore how elements within the same group exhibit similar chemical behaviors and how these properties vary systematically across the periodic table. Dear students, let's start from group 1 elements. All group 1 elements have just one electron in their valence shells and they are highly reactive. Hydrogen has one electron in K shell, lithium has one electron in L shell, sodium has one electron in M shell, potassium has one electron in N shell, rubidium has one electron in O shell, cesium has one electron in P shell, francium has one electron in Q shell. Except hydrogen, all other elements are alkali metals. They are in solid state. As you could see, sodium, lithium, potassium, rubidium, cesium and francium. Group 1, the alkali metals have a very specific electronic configuration. You already know that all group 1 elements have one electron in their outermost shell, giving them a strong tendency to lose this electron to form positive ions, cations. Moreover, alkali metals react with water to form water-soluble bases, alkalis, along with the liberation of hydrogen gas. Their reactivity increases as we go down the group, francium being the most reactive. The reason behind this trend is the gradual increase in size. Dear students, the reactivity of alkali metals gradually increases due to the gradual increase in the number of shells. That makes it easier to remove electrons. Hence, the effective nuclear charge decreases and the tendency to lose electron increases. So we could say that the reactivity of alkali metals increases down the group. The tendency to lose electrons increases. Let's study the reactivity of alkali metals with water in detail. These metals react vigorously with water, producing hydrogen gas and forming alkalis in solution. Video. Sodium reacts with water. Sodium with the symbol of Na is an alkali metal with the atomic number 11. Dear students, when you mix sodium and water, you get a highly reactive exothermic reaction. Now we are mixing sodium metal with water and you could see, wow, the reaction is vigorous with the liberation of hydrogen gas. So alkali metals react vigorously with water. Let's study further chemical properties of alkali metals. Reaction with oxygen. Oxides of alkali metals are strongly basic in nature and readily dissolve in water to form alkalis. For example, potassium oxide reacts with water to form potassium hydroxide. Reaction with halogens are extremely important. Alkali metals react with halogens to form halides. Sodium metal reacts with chlorine gas to form sodium chloride, table salt, a compound responsible for the salty taste in our food. How ionic bond develops in sodium chloride? The electropositive nature of these metals makes them eager to donate electrons in chemical reactions, explaining their high reactivity with electronegative elements. As you could see, the electron is being transferred from sodium metal to chlorine non-metal. The result is the formation of sodium cation and chloride anion, and there is ionic bond between sodium and chlorine elements. Then comes group 2, the alkaline earth metals. Group 2 elements show a tendency to lose both of their outermost electrons to form two positive cations. Like group 1, these elements are also electropositive metals, though generally less reactive than their group 1 counterparts. Alkaline earth metals include magnesium, beryllium, calcium, strontium, barium and radium. Dear students, all group 2 elements have two valence electrons in their last shell. Beryllium has 2 electrons in L shell, magnesium has 2 electrons in M shell, calcium has 2 electrons in N shell, strontium has 2 electrons in O shell, barium has 2 electrons in P shell, and radium has 2 electrons in Q shell, that is the 7th shell. Students, group 2 elements love to lose 2 electrons as they have only 2 electrons in their outermost shell. So, as you could see that magnesium atom is losing 2 electrons in its last shell to convert into dipositive magnesium ion. The reactivity of alkaline earth metal also increases as you move down the group. The reason is the increasing atomic size that results in less ionization energy, or in other words, the electrons from the outermost shell can easily be lost by the atom, as the grip of the nucleus on the last shell electron reduces due to the increase of the size. Moreover, the inner shell electrons form a sort of shield around the nucleus. Like alkali metal oxide, alkaline earth metal oxides also react with water to form water-soluble bases. For example, sodium oxide reacts with water to form sodium hydroxide, and similarly, calcium oxide, a member of group 2, reacts with water to form calcium hydroxide. Then comes group 17, the halogens. All elements in group 17 have an s2p5 configuration in their outermost shell. They show a strong tendency to gain one electron to form anions with one negative charge. Halogens are highly electronegative elements that readily form salts with metal. This property gives them their name halogens, that is, salt forming. Unlike alkali metals, the reactivity of halogens decreases as you move down the group. So these are the 4 main halogens: fluorine, chlorine, bromine and iodine. Dear students, we have already studied that there is a very strong relationship between metals and non-metals. We have read about alkali metals, alkaline earth metals, and now we are reading about halogens, which are non-metals. The basic difference between metal and non-metal is the tendency to lose or gain electrons. Halogens have the tendency to gain electrons, whereas metals have the tendency to lose electrons. You could see that calcium is having 2 electrons in its outermost shell, and it is donating these 2 electrons to 2 chlorine atoms. Chlorine atoms, being non-metals, have the tendency to gain electrons. As a result, we are getting 2 chloride anions and 1 calcium cation. Calcium cation has dipositive charge, whereas chloride anions have mononegative charge. This results in strong electrostatic attraction between calcium cations and chloride anions. Result is the formation of calcium chloride salt. Then comes group 16. Elements in group 16 have an s2p4 configuration in their outermost shell. They have a tendency to accept two electrons to form di-negative ions. For example, oxygen. Oxygen behaves as a strong electronegative element, readily accepting electrons to complete its octet. Students, after studying the group trends of group 1, group 2, group 16 and group 17, finally we are going to learn about the relationship between group number and ion charge. Moving left to right, main group elements tend to form cations with a charge equal to the group number. Group 1 elements form 1 plus ions. Group 2 elements form 2 plus ions. Group 3 elements form 3 plus ions. It means all these elements have the tendency to lose electrons. Whereas moving from right to left, elements form anions with a negative charge equal to the number of groups to the left of the noble gases. Group 17 elements form 1 negative ions. Group 16 elements form 2 negative ions. So, there is a huge difference between the ions of metals and non-metals. Metals lose electron, form cations. Non-metals gain electron, form anions. The number of charges on ions corresponds to the number of electrons in the outermost shell that are either lost or gained to achieve a stable electronic configuration like noble gases. So let's study the formation of anions in the periodic table with more detail. There is a general rule. When moving right to left in the periodic table, elements form anions. Charge is equal to the number of groups away from the noble gases. For example, group 17 elements located one group left of noble gases form ions with one negative charge, like chloride, fluoride and bromide ions. Example 2, group 16 elements located two groups left of noble gases form ions with two negative charge. Example, oxide and sulfide anions. So dear students, negative charges corresponds to the number of electrons needed to complete the octet. Dear students, whether metals or non-metals, they all make cations and anions to achieve noble gas configuration by obeying either duplet or octet rule. The transfer of electron forms one of the most important kind of chemical bond, that is ionic bond, which is formed between metals group 1, 2, 3 and between non-metals group 16 and 17. Dear students, let's focus on our key takeaways. Periodic trends in chemical properties. Group trends. Elements in the same group have similar chemical properties due to the same number of valence electrons. Both alkali metals group 1 and alkaline earth metals group 2 become more reactive down the group. Due to the expansion of atom, it becomes easier for metals to lose electron, so their tendency to lose electron increases. In other words, they become more and more electropositive down the group. What about group 16 and 17? They are electronegative and they are non-metals. These elements' reactivity reduces as you go down the group. The reason is that due to the expansion of atom, it becomes difficult for these atoms to attract electrons. So gaining of electron becomes difficult as you move down the group. So electronegativity of these elements decreases down the group. Hence they become less reactive. Trends along the period. Elements change from metals to non-metals across a period. It's a very important change, as slowly and gradually the tendency of losing electron converts into the tendency of gaining electrons. Electropositivity converts into electronegativity. Metals convert into non-metals. Secondly, ion charge is directly related to the group number. Why elements react? Elements react to achieve stable electronic configuration like noble gases. Understanding these periodic trends allows chemists to predict how elements will behave in chemical reactions making the periodic table one of the most powerful tools in chemistry. Dear students, thank you for listening. I hope you enjoyed learning. Jazakallah all.